Hi, this is Mrs. Yamamoto. Let's talk today about some negative exponent rules. So let's say you have a base of x, and your base of x has an exponent a, but that exponent is negative. A negative exponent just means that the base is on the wrong side of the fraction line, so you need to flip the base to the other side. So that means that x to the power of negative a is the same thing as x to the power of negative a over 1. And we want to write our exponents in positive form, so we're going to flip that, and now that same base of x is going to be on the bottom, and our exponent is going to be positive. Let's go ahead and simplify each of the following, and our answers are going to contain positive exponents only. So looking at number 1, remember, this is x to the negative fifth power over 1. So what I'm going to do is use that rule and flip the base to the other side, and our exponent becomes positive. So I'm going to get x to the fifth power, and there's nothing else on the numerator except for 1. So what I did was I took the base of x and the negative 5 and of the exponent and flipped it and placed it on the bottom. So here is our answer, 1 over x to the fifth power. Okay, let's go ahead and try another question. I have 3m raised to the power of negative 2. This is the same thing as 3m raised to the power of negative 2 over 1. And what I want to remember is that with my rule, my negative exponent rule, if I have a number in front of my variable, such as, let's say I have a number like 2x to the negative second power over 1, when I use the negative exponent rule, the only portion that gets flipped to the other side is the negative exponent and the base of that. And the base of that is just x. So x to the power of 2. And then this 2 right here, it stays on the top. So the only thing that moves down with the exponent is the variable. The coefficients don't move down. So in this case, I'm looking and I see I have m to the power of negative 2. That is going to move down. So I'm going to have m to the power of negative 2 is going to become positive 2 when I move it down. And then this 3 is still going to be on the top. So for example, if I had 4x to the negative fifth power, to simplify this, the variable and the negative exponent would flip to the bottom, and that exponent would become positive, but that coefficient still is on the top. Right, let's look at a third example here. So I have negative 7, a to the power of negative 4, b to the power of positive 3. So I have 3 separate parts here I want to look at. Which one of those 3 are going to flip or move to the bottom? The one that's going to flip or move to the bottom is a to the power of negative 4. So that's going to be a to the power of a positive 4. The negative 7 stays on the top along with the b. So here's my answer. See if you can try this question. So for this question, you would get negative 6b to the power of 5 divided by a to the power of 2. Here on number 4, notice that we have two coefficients. The coefficients are 6 and negative 3. And then we have 8 to the power of 8 and 8 to the power of negative 7. So before I flip and move an exponent to the bottom, one thing I want to pay attention to is that I have coefficients that are both next to the variable x. So I'm going to multiply those coefficients and get negative 18. And now I see that I have a base of x. When I have the same base and I'm multiplying, what will I do with these exponents? With these exponents, I'm going to add them. So if I add the exponents, that's 8 plus negative 7. And this is going to give me negative 18x to the power of 1, or just negative 18x. All right, let's try number 5 together. So number 5, here I have in parentheses 3x to the power of 3 raised to the power of negative 2. So first thing I'm going to do is remember that when I have an exponent outside of the parentheses, that gets distributed to both terms. So first I'm going to start with this 3. So this 3 has an exponent of 1. So 3 to the power of 1, if I distribute the negative 2, 1 times negative 2 gives me negative 2. And for my x to the power of 3, 3 times negative 2 is going to give me negative 6. So what do I know now about negative exponents is that they move to the other side and they take their base with them and become positive. So this 3 to the power of negative 2 moves to the bottom here and becomes positive. This x to the power of negative 6 moves to the bottom and becomes positive. On the top, I'm left with just 1. I can simplify this. What would I get? I would get 1 over 9x to the 6th power. All right, number 6. Number 6 is very similar to number 5, so I'm going to give you a few hints and let you solve this one, and we'll check your answer in class. All right, let's go ahead and try number 7. On number 7, I say I have negative 8 as a coefficient. That negative 2 is going to get distributed to the negative 8. So that negative 8 now is raised to the power of negative 2. Then I have x to the 5th power. The negative 2 gets distributed. And I have x to the negative 10th power. And finally, y to the power of negative 4. The negative 2 gets distributed. So I'll get y to the power of positive 8. So let's continue to solve here. My negative exponent rule tells me that if I have a negative exponent, it gets flipped to the other side of the fraction line. So negative 8 to the power of negative 2 gets flipped to their side. Now it's negative 8 to the power of positive 2. X to the power of negative 10 becomes x to the power of positive 10. And y to the power of 8 does not have a negative exponent, so it's going to stay on the top, on the numerator. So when I simplify this, I will get y to the power of 8 divided by 64 x to the power of 10. So please write that down as your final answer. So we're going to go ahead and skip number 8. We're also going to skip number 9. And we're going to skip number 10. And let's look at number 11. So there's a couple things we know about h to the power of 4 divided by h to the power of 6. We know that in factored form, I have 4 h's on the top and 6 h's on the bottom. And when I simplify and I cancel out, I have 2 h's left on the bottom, which means I have h to the power of 2 on the bottom and 1 on the top. And this is my simplified answer. We also know that if we have the same base, we can subtract the exponents. So h to the power of 4 divided by h to the power of 6. If I subtract, I get h to the power of negative 2. Why do I get negative 2? Because 4 minus 6 is going to give me negative 2. And our rule tells us that if we have a negative exponent, that it gets flipped to the other side. So that means that this goes to the bottom of the fraction line, and I end up with the same answer I got when I wrote it in factored form. So you could either, for a question like this, write it in factored form and simplify, or you could use a rule knowing that you subtract the exponent, simplify, and when you get a negative exponent, you'll have to remember to flip it to the other side. Either way, our answer is 1 divided by h to the power of 2. Right here on number 12, I have k to the power of negative 2. So there's a couple ways I could solve this question. The first thing I could do is subtract the exponents. That means this would be k to the power of negative 2 minus 7, which is k to the power of negative 9. And we know that k to the power of negative 9 is the same thing as k to the power of negative 9 over 1. And when I move this to the bottom, my new answer is 1 divided by k to the power of positive 9. The other way I could look at solving the question is by taking the k to the power of negative 2, realizing that it's going to move to the other side of the fraction line and become positive, so that will be k to the power of positive 2. The k to the power of 7 is still going to be on the bottom, and what's going to be on the top? Just 1. And here I can simplify, because if I have the same base, I can add those exponents, so I get the same answer I got, which is 1 divided by k to the power of 9. So before you come to class tomorrow, I would like you to try and solve numbers 13, 14, and 15. Good luck, and I'll see you tomorrow in class. Have a good day.